Alright, I'm Lochlan Durie, and this is my answer for the bonus problem 1 extra mark. To start with, I've just drawn a coordinate system with an x and y axis and then done a diagram of the trajectory of the shot. You can see there's two possible paths that go through the point P. There's one high arcing one and one low arcing one, both go through that point. The one we're interested in is the high arcing one because that'll drop quicker after that point and hit the water sooner. Just got the point at the peak of the mountain, which was 2500 and 1800, and the initial velocity is 250 meters per second at the angle theta. From there, I've just set up the function of x as a function of t, which is 250 cos theta t, and y as a function of t, which is 250 sine theta t, minus half gt squared. Solving it for at point P, in the x equation we have 2500 equals 250 cos theta t, which implies that t is equal to 10 on cos theta. That's our first equation. And in the y coordinate system we have 1800 equals 250 sine theta t, take half gt squared. Solving those two simultaneously, we get down to the next line and we get that 1800 equals 250 sine theta times 10 on cos theta minus g on 2 outside of 10 on cos theta all squared. Cancelling off some powers of 10, it goes down to 180 equals 250 tan theta, because sine theta on cos theta equals tan theta, minus 49 sec squared theta, because 1 on cos squared theta is sec squared theta. The next line uses the trigonometric identity for sec squared theta, and it goes 180 equals 250 tan theta minus 49, and the Pythagorean identity, which is 1 plus tan squared theta. And that gives us a quadratic on the next line. The line after that, I've subbed in let u equal tan theta, so we can solve it using the quadratic formula. So we get 49 u squared take 250u plus 229 equals 0. And then from the quadratic formula, you have the 250 plus or minus the square root of b squared take 4ac on 2a, and gives that two possible values for u. One is 1.20 and the other is 3.91. Taking the inverse tan, you get the two possible angles, which is 50.12 degrees or 75.64 degrees. From that, we can see that, looking back up to the diagram, if we reference back up, we can see that it's the higher arcing trajectory that we're after, because that's the one that's going to fall shorter after it passes the peak of the mountain. So we're looking at the 75-degree answer, and the formula for the range, which was derived the other week, was the v squared sine 2 theta on g. So subbing in the values there, we get a range of 3065.1 meters, which means that our distance from the shore to where the shot could possibly land in the water is that range minus the 2500 to the peak of the mountain minus the 300 from the peak to the shore, and that gives us 265 meters of safe water on the far side of the island that the shot could never reach, because it can never land in this area here. This is our safe water area, which is X, which is our final answer.